Going into Chapter 10, we're going to take a closer look at the algebra of functions. We're going to find the sum, difference, product, and quotient of two functions. We're going to graph the sum of two functions, and we'll also tie it into our graphing calculators. Now, I want you to take a moment, pause the tape, and copy this, particularly 1, 2, 3, and 4, where these are the rules. So we'll pause, and then we'll kind of go over what they mean. But copy these into your notes. Now we're going to look at the definitions very carefully. Again, this is the function symbol. So we're saying the function of x and another function, in this case g of x, represents two functions. And the x value that we see here and here in the domain of both functions. We then define the following operations. So this is the operation. We're adding the function of g and the function of f. And the x just refers to the expression that they're giving us for this function of f and this function of g. So we're just adding them together. Now, the difference of two functions, again, are just putting a negative sign between the two functions as they give us this direction. X refers to, again, whatever the function of f is minus the function of g. They're just showing it to us this way. Now, multiplication, the product, we are multiplying. We're going to multiply these two functions. And this is what we're referring to. And the quotient is division. So we're going to take the function of f and divide it by the function of g. And keep in mind that this function in the denominator here cannot be equal to 0, because that would be then undefined. Now, hopefully, as we give you the first example, you can see what this is all about. So again, in your notes, you're going to put example 1, and you're going to write this example. Now here, our function of x is this, and the g function is this. So, according to our rule, we're just going to add these two functions together. And again, you want a strategy for doing this, and I know in our 1103 class we suggested you line them up vertically. So x squared plus x minus 4. And now we're just going to put these under their like term columns. This is going to be plus x, and this is going to be a negative 6. Now, normally we don't write the 1 in front of the x, but if you want to for your calculations, that would be okay. So now we just add them up. 3x squared plus 2x minus 10 is our answer. So again, they're giving you some background on what these things mean and then how to execute it. All right, let's go on and see what they have here. They're doing it horizontally. That's okay. And you just add them up. And it gives you that. Now, for letter B now, they're asking us to subtract. So we can use a similar protocol, but we have to be careful because now, over here, instead of being plus, this is going to be in the sense of minus there. So let's set this up. So 3x squared plus x minus 4. Now, this is where it's a little tricky. You have to keep this in parentheses, and you're going to subtract it. So the technique of having a negative sign in front of parentheses, we remove the parentheses, and each of these terms, we change the sign. So you can think of this as being like a -1 in front. So -1 times x is a negative x. A -1 times a -6 is a positive 6. And again, I like the idea of lining them up in vertical columns. So notice what happens here. These are going to cancel out. So you're going to get 3x squared. This cancels out, and you end up with plus 2. Again, the shortcut rule here is if there's a negative sign in front of parentheses, you just remove the parentheses and change each of the signs. A common error is the student will only change the first one and not the second. And of course you get it wrong. But again, we're showing you in operations with functions what this means. You have your f, you have your g, and then they're just saying subtract them. Up here they're saying add them. And this is just the way they show it here. Alright, let's go on and see the answer. Now again, they're not working it out for us, but they're just showing the answer, but we're giving you a little more detail. Okay, now what you have to do, of course, is remember what this was. And if you recall, let me write it out here for you. This was 3x squared plus x minus 4. That was what the f was. And now we're going to multiply it by g. And if you recall, g was x minus 6. And we're going to do some multiplication. So again, you could do it horizontally, but I like this idea of vertically. So let me do that for you and save a little time. So we're going to multiply a -6 times a -4 and get a positive 24. -6 times x is a -6x. -6 times 3x squared is a -18x squared. So I'm using this long form of multiplication, putting the terms in like columns. Now x times -4 is -4x. X times x is x squared. And I'm putting a 1 there just for calculation purposes. And then x times 3x squared is 3x cubed. Put my line, and now I'm adding up my like terms. And again, we're showing you some techniques that may be useful in doing this. But again, what are they asking? You are multiplying these functions, and you want to know what to do when you see something like that. Okay, let's go on and check it out here. And they're just giving you the answer. But again, that's what they're doing. All right, now before we go on, we want to evaluate each of the functions found in A through C, where we're going to say that x is 2. So let's look at this here. So initially, we get our final answer. You go back, and you recall this is what we got for A. We're going to put a 2 now. We're evaluating the x in this expression as a 2, and then we just do the operation. Now let me do this one for you. So 2 squared is 4. So we have 3 times 4 here. 2 times 2 is 4. Minus 10. So this is 12, this is 16, minus 10 equals 6. So you have these written up in your booklet. You just want to evaluate by substituting an x, the x with a 2. And that's how you would do it. And again, on your blue sheets, this is what you want to show. Now, when we do the substitution for the subtraction part, which was B, we're going to put a 2 where each of those are. And remember, this is what we had. 3x squared plus 2. X squared is going to be 4. So 3 times 4 is 12, plus 2 is 14, yes. And then we're going to substitute this. Here we had to cube the 2, square the 2, just multiply by 2. And again, it's giving you a little bit of practice in arithmetic, and it ends up being a negative 40. Okay, now we're going on to example 2. Now as you look at this, you'll notice it's the same operation. We're going to add the function of f to the function of g. So it's this added to this. And again, I would suggest x squared minus x. And this is going to be plus 2x plus 1. Keeping in mind there's a 1 there, we're just going to add them together. X squared, this just becomes plus x plus 1. So pretty straightforward as long as you understand what's going on here. And there it is. Now for B, we're going to do the subtraction. So we have x squared minus x on top. Now here, instead of a plus sign, remember it's going to be a negative sign. Take away the plus because we're subtracting. And then to subtract, we remove the parentheses, change each of these signs. So this becomes a negative 2x, and this becomes a negative 1. Remember, you can think of it as a negative 1 times this is this, negative 1 times this is this, or just remove the parentheses and change both signs. Add them up, x squared, Remember there's a 1 there, so that's negative 3x minus 1. And there's the answer. Okay, now what we haven't done yet is do this division. And you need to, of course, remember what the function of f was. So let's just set that up. You recall f was x squared minus x, and then you're going to go 2x plus 1. Now, can you do any simplification here? And the answer is no. For instance, you might think you could factor out an x there and get x minus 1, but there's no common factors. So this would be your answer. And then later they're going to ask us to substitute and evaluate that. And we have to keep in mind now, yes, I want to bring this up here. When we define the domain of something like this, remember domain would be your x values, and then often it's from negative infinity to positive infinity. But here we have to be careful, because if x were to make our denominator a 0, then that value of x is not included in the domain. And they're showing us that. So let's do it. What would make our denominator a 0? Well, if we solved our denominator, we're saying what would make it a 0? Well, you would transpose the 1, that would be a negative 1, and then you would divide by 2. So if x were a negative 1/2, let's do that. 2 times a negative 1/2 plus 1. Well, here the 2's cancel out, and you get a negative 1 and a positive 1. That would make your denominator a 0. So they're saying, as far as the domain goes then, for when we have division, any value of x that would make the denominator a 0 is excluded from the domain. That is, x cannot be a negative 1/2. And if you were to write that in interval notation, it would look like this. You'd go from negative infinity all the way up to a negative 1/2, and you'd use a parenthesis because it doesn't include negative 1/2. But then you would use the union symbol and then start on the other side of negative 1/2, and that would go to positive infinity. And that would be the domain of this function. It would include all real numbers, but not a negative 1/2, because the negative 1/2 would make our denominator a 0. Okay, let's go on. And they now want you to evaluate each of these when the value of x, its replacement, is 3. So they will do that for this first one. There's what we got for a. They're substituting a 3, and it becomes a 13. And there's our b, substituting a 3. Now remember, it's not substituting a 3 here. It's the answer we got for b, which was a negative x squared plus 3x plus 1. Here the answer is 1. And when we did this division, putting a 3 in there, we end up with the fraction 6/7. Again, they're testing your arithmetic skills a little bit too, but you want to know the operations that are going on in the background to give you these results. Okay, let's take a look at this one now. Now, I set this up a little bit because this is rather easy. We're just going to add this to this, which is what I have here. But they're also asking us to find the domain now of this. Well, there is a limiting factor to our domain because of this radical sign here. Now remember, we can't have a negative value under the radical sign. So in something like this, we have to say, what would be the value of x that would make this true, or be a real number? Well, we take our radicand, which is x minus 2, equal it to 0. It has to be greater or equal to 0. And we get x is greater or equal to 2. Now you might think, well, this one wouldn't have any restrictions, but since you're joining these through addition, it now has a restriction because one of the x values is under the radical. So, how would you write then the domain? Remember, if we put this on a graph at 2 here, this is included in the set, and they're saying x is, now we use a bracket, like so. So these are the values of x, restricted because of this radical sign here. If we didn't have this radical sign, then it would be all real numbers. So our domain then is bracket, 2 is included in the set, and it goes to positive infinity. Remember, infinity always has a parenthesis. Now I see we're running over our 20 minutes, but we're almost finished, so we'll move on here shortly. And they're saying they have to define what your values of x because of the radical sign. So there is the domain. Now how about, for example, 3? You want to write this down. And you end up with something like this. Well, again, you are restricted by this. And any value, as we see here, that would make our denominator a 0, of course, you can't have that. So it's not going to be greater or equal to 0 as it was in the numerator, but in the denominator you cannot, and I'll repeat this and emphasize it, you cannot have, when you solve this, it's x is greater or equal to 2. In the previous one, you now cannot have that negative here, because that would make it equal to 2, and this cannot be 2, because that would make the denominator a 0. So the difference here is that you can't have an equal sign in that denominator, so we have to take that away. And then our when we list the domain, instead of having a bracket as we had before, 2 comma positive infinity, it's going to be a parenthesis, because 2 is not included in the set. Having it a 2 in the denominator would make our denominator a 0. But just the other side of 2, then we are okay. So it'd be like 2 point, a little bit of a fraction here, and then that's okay. All right. So some background. All right, let's take a look at this now. Sally is analyzing the finances of her bakery. She finds that the bakery revenues can be represented by this function. When they sell this many cakes. The cost function can be represented by this. When they make the cakes. Using the formula profit equals revenue minus cost. Find an expression that represents the bakery's profits when they sell X case. Now, you may or may not have had this in the past, but we often think of profit function is equal to revenue function minus cost function. And that's what they're saying here. So revenue is this, 23x plus 18 minus, now we have to put this cost function in parentheses. So what happens here? Well, when we subtract the cost, we have to remove the parentheses, so it's 23x plus 18. Now this becomes a negative 8x. Now the opposite, and keep in mind you could put a 1 there as we did before, this becomes a plus 4. So we're going to subtract 8 from that, and this gives us 15x. And we're going to add 4 to this, which will give us a 22. So this should be our profit function. And this is the background. And remember, this is example 4. This will be in your notes. You don't have to write the problem out here. All right, let's see what they have. Good. And there's the answer. Okay, we are over, so we're not going to do this, but we'll pause here for a moment in case you really feel you want to put some of this in there. Pause it and work these, and then there's some more. And there are the answers. And we'll wind up.